In chapter 2 electrostatic, the next topic is capacitance. Capacitance is a device used to store electrostatic potential energy and charge. The capacitance is a device which can store more and more charge. It is represented by capital C, as we represent the resistance by R and battery, all devices in the circuit. Here the capacitance is represented by capital C. Its SI unit is farad. The charge given to one plate of the capacitor is directly proportional to the potential difference between the two plates. If we make a formula from it, the Q is equal to CV. The C is the capacitance. It can be written as C is equal to Q upon V, where Q is the charge and V is the potential between the two plates. C does not depend upon Q and V, because when Q increases at the same time, V will increase. If Q is decreases at the same time, V will also decrease. The value of C depend on the area of the plate, distance between the plates and the medium between the plates. We have three kind of capacitor. One with the air, other with the conducting slab, and one more is there with the non-conducting or dielectric in between the plates. If air between the plates, we can calculate the value of C is equal to epsilon. Epsilon is given for the medium between the plates. A is the area of the plate and D is the distance between the plates. The second is the conducting slab between the plates of the capacitance. That conducting slab is having the thickness of T and the distance between the plates is small d. First plate is positively charged, second plate is negatively charged. If we calculate the value of C, it comes to epsilon naught A D minus T. The D minus T has come because the T thickness will also conduct. All negative will come towards positive and all positive will go towards negative. So it will create an electric field opposite to the electric field in between the plates. So the net electric field in the plate D is equal to 0. So we can say that C is equal to epsilon naught A upon D minus T. In the third way, the capacitance with dielectric. First we have done with air, then we have done with conducting slab, and this is the third one where we are there with the dielectric in between the plates of the capacitor. Dielectric are those insulators which behave as a dipole when they are applied with the electric field. Here the electric field is due to this plate is positive, this plate is negative, so the electric field is from positive to negative. Now when the dielectric is placed in a strong electric field, the every atom will convert into a small dipole, and this will create an electric field in the opposite direction. Because the electric field in the opposite direction, which is very less than the electric field outside. If we found the formula for it, so C is equal to epsilon naught A upon D, distance between the plates, minus T, thickness of the slab, plus T by K. This K is dielectric constant of the material which is kept in between the plates. The K can be calculated the capacitance with dielectric upon capacitance in vacuum. Now the next topic is combination of capacitance. This capacitance can be connected in two ways, series and parallel. Let us see what happen in series. C1, C2 and C3. As we know that the current is same in these, but the potential will be different. If we find out the potential, we get the formula 1 upon Cs. S is representing series, is equal to 1 by C1 plus 1 by C2 plus 1 by C3 and so on. The second combination is parallel. Now let us see, we have three capacitance in parallel combination. As we know that when there is a parallel combination, the potential is going to same and the current will divide into 3. If you find the combination formula, the Cp comes to C1 plus C2 plus C3. Now these two combinations are totally inverse with the resistance. With the resistance in combination we get this formula, and in parallel we get this formula. The next topic is energy stored in capacitor. As you know, in the beginning we have written the capacitance is used to store energy and charge. The energy can be given by half CV square, but Q is equal to CV. If we put the value of that, then it becomes Q square upon 2C. Both the formulas are same. Next is energy density in capacitor. Density of energy in the capacitor, that is given by energy upon volume. Energy volume this given by A into D. As you have seen the figure, A is the area of the plate, D is the distance between the plates, so this becomes volume, and this is the energy from this formula. We know that the C value with air came to epsilon naught A by 2, and V value we can write ED. ED is the for relation between V and E. So it is square. So we have written E square V square upon volume AD. Now we are having two D's here and D square here. So they will get cancelled. A and A will get cancelled. The energy density for the capacitor is now half epsilon naught E square.